Hello and welcome to the demonstration of my project Automatic Image Enhancement and its compression. Let me start my presentation with the output of my project. The left hand side image shows the input, whereas the right hand side is the output. It can be clearly seen that the left hand side of the image has some inferior qualities in comparison with the right hand side of the image. Our main aim in this project is to enhance every image that is submitted to this algorithm. So let me just show you another image to demonstrate the power of this algorithm. And yeah, here we have it. The left hand side image is overexposed to the brightness of the image, whereas the right hand side of the image has preserved some of the details. It has obtained the details from the left hand image. So let me delve into my presentation to brush up the finer details of the project. So our main aim is to provide good high quality images automatically. The user has to just submit an image and the output of the image that is obtained should be of high quality. So when we talk about quality, there are certain aspects of an image which determine the quality of an image. Some of them, the most important of them, are contrast, brightness, noise and sharpness. These four quantities actually influence the entire image. The aim of the project is to control these parameters in order to get the good quality image that we actually perceive in our human eye. So the parts of our project are to individually deal with all these four parameters and then combine it into a single project and then use compression techniques to save the file. So let me start with brightness, which is the first parameter. Brightness can be defined as the amount of irradiation from a source of light. The brightness information is actually mathematically related as luminance. The luminance part of an image or a pixel is very important in consideration. This is because of a simple fact. Our eyes are made up of a number of rods and cones, which are cells which are used for perceiving the visual system. The rods present in our eye actually obtain the luminance information and the cones present in our eye obtain the chrominance information, that is the color information. Since the number of rods is greater than the number of cones, the luminance information is very important. In this project, we actually average out the brightness present in the entire image. We just take 3 by 3 windows, obtain the brightness of the image and spread it to the entire window. This method is called method of means. Next, let us deal with the most important parameter of the quality of an image, that is the contrast. The contrast of an image is actually defined as the amplification of the small differences of luminance. So here we deal with the discernible feature of a pixel from its neighborhood pixels. In visual perception, contrast is determined by color and brightness. So this is an example of contrast. This is a low contrast image and this is a very high contrast image. It can be seen that this image can be considered to be having a higher quality when compared with the left hand image, whereas the extreme right image is considered as a low quality image, though it has a very high contrast. Therefore, there are these threshold values which should not be exceeded in order to get this natural contrast in our images. So there are different types of approaches in order to improve the contrast of an image. The different types of approaches are linear stretching, non-linear stretching, histogram equalization and adaptive histogram equalization. linear stretching and non-linear stretching cannot be used in our project based on a simple fact. The linear and non-linear stretching actually depends upon the input of the image. It obtains the threshold values, thereby it can use those threshold values to spread the amount of pixels present in a particular range. However, when we use histogram equalization, it becomes independent. So these are the outputs that I got. This is the input image, this is the histogram equalized image, and this is the adaptive histogram equalized image. It can be clearly seen that the histogram equalized image is of very low quality, whereas the adaptive histogram equalized image is of high quality. We preferred adaptive histogram equalization in order to overcome the difficulties present in histogram equalization method. Histogram equalization method is affected by the fact that it uses only one histogram to actually equally distribute the amount of pixels present in the image. Therefore, the background information of white pixels is actually spread to the entire image, causing this blurry, hazy effect. Whereas when we use an adaptive histogram equalization method, each and every aspect has different types of boundaries, and these localized areas are used for discerning from one another. Here, the pixels present in this area are spread throughout this range, thereby providing a better filter in comparison with histogram equalization. Therefore, the best method that we adopted in our project is adaptive histogram equalization because of its high computation power. The clip size we used were 0.01 threshold, which normally tested to be the ideal value. So let us delve into the next important aspect of an image, that is the noise. So noise is basically the unwanted signal present in a system. Noise usually distorts the system. There are different types of noises like white noise, sandpaper noise, and salt and pepper noise. So there are different types of approaches that can be used for reducing noise present in a system. We can use different types of low-pass filters like average, weighted average, symmetrical filters, or adaptive filters. The one which we use in this project is a median filter. But there is this problem which is always associated with noise. Whenever a random noise is provided in a system, it cannot be easily removed. We can remove speckles or dots or noises which can be determined mathematically. However, we cannot automatically remove the random noise present in a system. Medium filter is used for removing the speckles of dots. Here we show an input image in which salt and pepper effect is given. It can be seen that the noise is not entirely removed, but it is removed to quite an extent. So the problem arises when there are these two contradicting factors, sharpness and noise removal. This because whenever we remove noise, we can see the blurry effect. It smoothens the image. That is the opposite of sharpness, thereby causing this problem. Therefore, what is sharpness? Let's first define sharpness. Sharpness is the level of detail present in the system. It distinguishes the edges. It provides us the details of an image. So when we smoothen an image, it gets blurred. The detail is reduced. The texture of the image is reduced. Therefore, the sharpness is reduced. Therefore, we have to find a perfect balance, a trade-off between noise removal and sharpness of an image in order to obtain a perfectly ideal system, which is not possible. Therefore, we go into trade-offs. There are different types of approaches for improving the sharpness of an image. We use Gaussian high-pass filter because Gaussian high-pass filter gives a very high-quality image. A Pruitt or a Sobel filters cannot be used because they emphasize the horizontal edges, whereas they do not emphasize the vertical edges, and we might not know which is the more important edge in a particular image. Since we use Gaussian, there will be a trade-off between the horizontal vertical edges emphasis. However, the image produced automatically will be a very good image, a better quality image than the original present in the system. So let us now talk about the compression of an image. So why do we require compression? Images are stored as files and it requires space. If we remove the redundant space, we would get more space. Therefore, we use compression. Compression removes these irrelevant and redundant bits, thereby providing us with more amount of space with which we can play. So when we think about this compression techniques, there are predominantly two important types of compressions: lossy compression and lossless compression. A lossy compression is one in which the bits are approximated, some of the bits are lost, thereby there will be a loss in information. However, in most cases it is not visible to our human eye, it is imperceptible. The compression ratio obtained by lossy compression is very high, whereas in lossless compression the unwanted bits are only removed, thereby preserving the entire information of the image. There is never a loss of information in lossless compression. So the most important type of lossy compression that we use in day-to-day life is the JPEG. The JPEG algorithm is pretty simple, which we have implemented in our project. The RGB component is converted into the luminance and chrominance components. The chrominance component, since as I said earlier is now the important part, is reduced by a factor of 2. A discrete cosine transform is applied to the 8 by 8 factors of pixels. The amplitude of the frequency of the system for lower frequencies are taken into account because our human brain is more susceptible to those information. The resulting 8 by 8 block is then coded in a zigzag manner, thereby obtaining a 1D array. The 1D array is then encoded using Huffman's code or its counterparts like scalar coding, arithmetic coding, or run length coding. This is the base of the image. It gets zigzagged. This is the most important. Then it goes here, then it goes here. It goes in that zigzag manner. So this is the final output that I obtained by applying all these factors. This is the input image and this is the output image, which I have shown earlier. And I apply a grayscale image. It can be seen that the underexposed parts are also enhanced. And this is the output of my final image of overexposure. Therefore, it can be seen from all these previous examples that this algorithm also avoids overexposure and underexposure problems present in a system. It can also be seen that this system can be used as the initial adjustment for photometry. Also, it is very efficient and effective. The future scope of this project is that the JPEG encoding can be replaced with any lossless coding. Thereby, this project can be easily applied to a non-invasive early detection for skin cancer using the THZ method, terahertz method. Then this type of algorithm can be used in storing in cameras. It can also be used in vehicular tracking system. Therefore, it has a wide range of applications. It can easily process any type of image that can be given as an input. Therefore, this can be considered as a future implementation with larger application. Thank you.